Hi, I'm Ms. Stevens. If you're studying functions and want to learn about function notation and evaluating functions, you're in the right place. This episode will focus on using function notation correctly, evaluating a function at a value in its domain, evaluating a function at an algebraic expression. I'll start by providing a short lesson and then walk through a few sample problems. Let's get started. Function notation provides an abbreviated method for describing what result comes from plugging in an input. Recall that when a function f is defined with a rule or an equation using x for the independent variable and y for the dependent variable, we say y is a function of x to emphasize that y depends on x. We use the function notation y equals f with the x in parentheses to express this, and we read it as either f of x or f at x. The letter f is the generic term given to this function, and f is the most common name, but g and h are popular function names as well. You can use whatever letters you want, and when we get to applications, you'll see much more variety as the letters typically correspond to what they stand for in real life. For example, y equals 3x minus 5 represents a linear function. So we can name this function f and write f of x equals 3x minus 5. Again, f of x is just another name for the dependent variable y. Given that f of x equals 3x minus 5, f of 2 equals 1 means that in the function f, if x equals 2, then y equals 1. We also know the ordered pair, 2, 1, is a point on the graph of f of x. We can use this function notation to describe any other ordered pair on the graph as well. I can look at my graph and see that it crosses the y-axis at -5. That means f of 0 equals -5, or the point 0, -5 exists on the graph. I can also see that at 4, y is equal to 7, so f of 4 is equal to 7, or the point 4, 7 is another solution or another point on my graph. Let's try our first example. Let g of x equal the absolute value of x minus 2 plus 5. Find each of the following. All we're doing is evaluating our function g when x equals -4. So let's plug it in. G of -4 equals the absolute value of -4 minus 2 plus 5. And then we just simplify. -4 minus 2 is -6. The absolute value of -6 is 6. Plus 5, that gives us 11. So g of -4 equaling 11 means that the point -4, 11 is on the graph of g of x. Let's try another one. G of 3. Again, I'm going to plug in 3 for x and simplify. 3 minus 2 in the absolute value bars plus 5. 3 minus 2 is 1. The absolute value of 1 is 1. And 1 plus 5 is 6. So g of 3 equals 6. Or we can also say that the point 3, 6 exists on the graph of g of x. Pretty simple. Not only can you evaluate a function at a numerical value, but also at an algebraic expression. The same logic follows. Plug in the expression wherever there's an x and simplify. Example 2. A function f is given by f of x equals x squared plus x plus 10. Find each of the following. F of 5m. Okay, so wherever we see an x in the function f of x, we're just going to plug in 5m, and I'm going to use parentheses. So x squared plus x plus 10 becomes 5m squared plus 5m plus 10. All right, I won't get a single number out as a result, but I'll get a simplified expression. So 5m quantity squared means I'm going to square the 5 and I'm going to square m. So that becomes 25m squared. There's nothing else to do with 5m, so we'll take that out of the parentheses and we'll add 10. I'm going to double check to see if I can combine any like terms. I can't. I have an m squared, an m, and 10. So that's my final answer. F of 5m equals 25m squared plus 5m plus 10. Let's try another one. Same initial function, but now f of w minus 3. Same thing. Everywhere I see an x, I'm going to plug in w minus 3. So w minus 3 squared plus w minus 3 plus 10. And now I simplify. Remember that w minus 3 quantity squared means w minus 3 times w minus 3. You can't distribute that square. Plus another w minus 3, which doesn't need to be in parentheses, and plus 10. Okay, distribute. You'll get w times w is w squared. You'll get a negative 3w and another negative 3w, so altogether negative 6w's. And then negative 3 times negative 3 is positive 9. I'm going to rewrite the rest. And now I do have like terms. So I've only got one w squared, but I have a negative 6w and a positive w. I also have some constants to combine. I have a positive 9, a negative 3, and a positive 10. So altogether, I have a w squared, a negative 6w, and a positive w make negative 5w's, and a 9 and a negative 3 make 6, plus 10 is 16. Let's try one more together. Same function, but now I'm asking you to do f of h squared minus f of h plus 1. We're going to do these one at a time. So I'm going to start with f of h squared. All right, again, I plug in h squared anywhere I see an x. And I simplify. H squared squared is h to the 4th plus h squared plus 10. I can't simplify that any further, so I'll leave it as is for now. All right, on to f of h plus 1. We plug that in everywhere we see an x. And we simplify. Remember from before, h plus 1 quantity squared means h plus 1 times h plus 1 plus h plus 1 can come out of the parentheses and a plus 10. When we distribute, we'll get h squared, 2 h's, and a 1, and I'll write the rest. And we combine like terms. So only one h squared, but I have 2 h's here, another h here, and then for constants, I have a 1, another 1, and a 10. So grand total, I have an h squared, I have 3 h's, and I have 12. All right, we're not quite done. We need to do f of h squared minus f of h plus 1. So if I combine those two pieces together, f of h squared minus f of h plus 1 is going to be h to the 4th plus h squared plus 10 minus, in parentheses, h squared plus 3h plus 12. I'm going to distribute that negative. H to the 4th plus h squared plus 10 stays the same, but now I get minus h squared minus 3h and a minus 12. And again, I combine like terms. There's only one h to the 4th. There's a positive h squared and a negative h squared. Those are actually going to cancel each other out. There's only one h term, so that stays the same. And then I'll combine positive 10 here and a negative 12 here. So grand total, h to the fourth minus 3h, and then minus 2. So f of h squared minus f of h plus 1 is going to give me h to the fourth minus 3h minus 2. Now it's your turn. Pause the video and try this next one on your own. Example 3. Let f of x equal 3x squared plus 5 and h of x equal 2x minus 7. Find the following. A is f of negative 5. Let's see how you did. There's two functions here, so we want to make sure we pick the right one. F of x is 3x squared plus 5. So everywhere we see a x, we're going to plug in a negative 5 instead. So 3, negative 5 goes in parentheses. That's squared plus 5. Since we plug in a number, we're going to get a number out as a result. I just need to simplify. 3, negative 5 quantity squared is going to be 25, and then plus 5. 3 times 25 is 75, plus 5, and that gives me a grand total of 80. So remember what that means. F of negative 5 equals 80 means that the point negative 5, 80 is on the graph of f of x. Let's try another one. H of m cubed plus 8. Again, we have two functions. I want to make sure I pick the right one. H of x is 2x minus 7. So I'm going to plug in m cubed plus 8 for x in that function. I get 2 parentheses m cubed plus 8 minus 7. All right, and I distribute 2m cubed plus 16 minus 7. I find my like terms, positive 16 and a negative 7, and then I just combine for my final answer. So 2m cubed plus 9. Okay. Let's try one more. F of c plus 1 plus h of 3c. We're going to use both functions this time. And again, I'll do one at a time just to make things a little more simple. So f of c plus 1 becomes 3 c plus 1 quantity squared plus 5. That really means 3 c plus 1 times c plus 1 plus 5. I can distribute the 3 now, or I can wait. My preference is to wait, because I know that c plus 1 times c plus 1 is going to give me c squared plus 2c plus 1. I still have that plus 5 at the end. And now when I distribute, I get 3c squared plus 6c plus 3, and then I still have my plus 5. Again, we combine like terms. I have a 3 and a 5 here. So my final answer becomes 3c squared plus 6c plus 8. All right, part 1 complete. Now I'm on to h of 3c. I'm plugging that in for x. 2 times 3c minus 7. And I simplify. That's 6c minus 7. So now that I have both expressions complete, I'm going to combine them together. So f of c plus 1 plus h of 3c becomes 3c squared plus 6c plus 8 plus, I'm going to put it in parentheses even though it's not really going to make a difference, 6c minus 7. All right, again, I want to combine like terms. I only have one 3c squared, but I have 6c's here and another 6c's there. I also have a positive 8 and a negative 7. So when I combine like terms, I end with 3c squared plus 12c's plus 1. So f of c plus 1 plus h of 3c comes out to 3c squared plus 12c plus 1. For more step-by-step guided practice, check out the accompanying behind-the-scenes episode for this video. Remember that developing a solid understanding of math takes time and practice. If you liked what you saw today, please like, subscribe, and tell your classmates. Thanks for watching. I'll see you after class.